Yeah. So, hi everyone. I hope that I'm audible and visible to each and every one of you. Right? Yeah. Perfect. Perfect. I can see that. Okay. Perfect. So, welcome to this session, which is about machine learning and scikit-learn, which is a very awaited session of yours. And I'll just quickly introduce myself. I am Jayan Gupta, and I'm a member of technical staff at Geeks for Geeks. And today I will be, taking this session of yours, like this particular topic called machine learning. Right. So what I'll do is I'll just quickly, as well as share my screen, so that you guys can see this particular screen. Perfect. Yeah, I hope so. That must be visible now. So before moving forward, I just want to like address this particular part, that what basically is machine learning, right? Like what actually are we referring to as machine learning? Why is it so popular? Why is everyone just talking about machine learning? What is actually the use case of machine learning, and so and so. Now the fact is that if I talk about this particular thing, that what basically is this term, which we in short call ML, which is nothing but your machine learning. It is like a new way in which we basically are coding stuff now. And what do I mean by that? Previously, what used to happen was we used to follow a traditional approach. That means we had some kind of a problem with us, and we used to have some questions, and on the basis of that I used to compute maybe like an answer towards that particular problem. This is what we used to do. For example, if I had to like calculate, let's just say, body mass index, which basically stands for BMI, it has a particular formula that I had to include in my logic, or maybe in any kind of program that I used to type in. But now what is the change that we can observe is that now what we do is, for any given problem that we have, for every given problem that we just feed our data into a model, and on the basis of that, what we expect is that the model is now going to be automatically, by learning some patterns or any kind of thing, is going to be giving me some answers. That is what basically in a nutshell we can call about machine learning. Right? If I try to showcase you the same thing using like this particular tabular form, you can see that it is not just like a better form of coding or something like that. It is just like a change of perspective that we have in now for solving any problem. Like you can see that usually we had some data or any kind of problem statement that you used to have, applying some rules, whether that be if else statements, for loops, or any kind of functions, we used to like get to an answer. That's the thing. But now the change is that what we are usually doing is that we give the data, we have some answers to it, we have some, like labels to it, which will really, looking at it in a while. And on the basis of that, we expect the model to learn some rules on its own. And on the basis of that, we preserve, or you can say, move towards an answer. Okay. Now, moving forward, you will be able to see that this thing is kind of, like everywhere. We have machine learning in each and every aspect of our life. The best and foremost example being that you can see that it is, used in your email spam detections. Like whenever you used to have emails, like you must have seen in your Gmail accounts that now you have this section of spam emails. Like it's been a while now, but you must have seen it earlier as well. And it is able to automatically classify your emails into, like ham and spam. Like if it's a spam email or if it's a non-spam email, it is able to do it. So now the thing is, I don't think so that somebody is going to be in the back end going to read the email wholly, or you can say it's going to be reading the full email and then, like give you an answer to that. Then how is it happening behind the scenes? We have some algorithms for it, and these algorithms are nothing but machine learning algorithms. I hope so that watching movies, listening to musics, is a really good habit to have, and maximum people must be having. And you must see that in Netflix and Spotify, what happens is that the kind of music I listen to, or maybe the kind of movies I like to watch, videos I like to watch, people I try to follow, people just like them, or content just like that appears to me out of thin air. But this is not something which is magic. It is also possible to that particular thing. And before that, I don't think so that these kind of problem statements were able to be solved by traditional traditional programming. Moving on, you can see that in the fraud detection systems, there is a lot of use of machine learning, because there are chances that humans might miss some patterns, or get biased towards some answers. So given that, what we do is we have an algorithm for that too, that is going to be giving me the fraud detection part as well. Okay. Then we have the medical diagnostics. That means instead of manually going to a doctor and I'm not saying that these machines can actually replace a doctor, but certain processes are something which can be, done despite just going to a doctor directly. And what are those processes? I mean that instead of us actually going for something such as for, like looking at your reports or looking at your medical history, like your age, your BMI, your blood sugar level, your cholesterol, given these parameters, now we have certain models that might be able to calculate the risk factor that you're having. Maybe you might have a heart disease, maybe you might have, let's just say, tuberculosis or something like that. That is the real world examples that we are seeing. I hope so that this must be really nice. Okay, that's nice. Moving forward, what I want to talk about is that we have three types of machine learning that are involved. The first being your supervised learning. That means we have a supervised learning model, which we will be talk about what it is basically. Then we have unsupervised learning. Then we have the reinforcement learning. Now, when I talk about a supervised learning, in this, that actually the training is what it is different. When I talk about supervised, like when I talk about supervised, we need to understand that the data that we are going to be passing in needs to have some labels. Or you can say that, just imagine that we have a child with us, right? We have a child with us, and when we were actually ourselves younger, our parents used to teach us some things. For example, parents teach their children like this is a ball, or maybe this is a circle, or maybe this is a square, and maybe this is a triangle. They just don't randomly give you shapes to learn from. They actually have like terms attached to it, like this is a sphere, or maybe I should call it circle because it is in 2D. So I should say that this is a circle. Let's just say that this is a square, and let's just say that this is a triangle. Now, whenever this type of learning is involved, when we have a target label with us, that means we already know the answer. I just want that given these answers, the model is able to understand the pattern behind it. That basically comes under your supervised learning algorithm. And it is the most used algorithms in the world, like in terms of machine learning, they are very well used, right? Then another type of data that we have is basically your unsupervised learning. Like, what do you mean by these unsupervised learning? By unsupervised learning means that, for example, if I, let's just say, try to draw this particular thing, I'm not really good at drawing, that you might be able to see, but if I try to draw it, and I have in this case this particular thing, again, not really good at drawing, just bear up with me. Chicken. Sorry. Now, let's just imagine that these are two type of things that you are expecting in a basket. Okay. Now you just, instead of giving answers to what is what, you just try to give this basket to a kid, or maybe someone who has never seen these objects. But let's just say they are like a lot of this object and a lot of this object, but only these two objects are there in that basket. Now what will happen? There might be the case, like if I wanted this basket, then I give it to a person or maybe a kid, and I ask it to like maybe find some pattern. Like I just ask that particular kid to find pattern or anything like that. What will happen is that instead of actually me telling that particular kid or that particular model that what actually I'm looking for, that particular kid or model, anything, like I'm just using an analogy of the kid, would be able to decipher that we have this as a unique object, and this is what we have a unique object. That is what we are expecting that particular kid to do. And this type of training where we actually lack labels, where we actually do not have any kind of labels, is what we call as unsupervised learning. Okay. I hope so. This must be very, very clear. Perfect. This is like the second type. The last type that we have is basically your reinforcement learning. Now, reinforcement learning is basically based on the reward and punishment system. Now, let's just imagine, like I just try to explain you this in the most simple way. Let's just say that you are playing a game called tic-tac-toe. I hope so. You must have played that game in a while. Now, what we basically do is we have like these X's and then we have these O's. Now, there is a pattern to this game. That means whenever you get any consecutive things like three objects in one particular line, you win. That is what we have. Now, let's just imagine that this is a game that I want my model to learn. Like this is a pattern which I want my model to be learning. So what I usually do is, like whenever, in this case, if the model, let's just say, makes the right choice, let's just say I'm imagining that this is something which I'm calling as the right choice, I reward that particular model. Let's just say I give it points, like I give it a point or anything like that. And whenever like the model which I'm using is going to make a bad choice, for example, like in this game, it is quite possible that if you try to play it with a kid, or like just imagine machine learning models as a kid, he or she might be doing it in this way also. So what we usually do in this case, either rewarding that particular step, what we do is we give that particular model a punishment. That means I may it give a negative score or something like that. Now, through this kind of training, what we are actually expecting is that we expect that the model is able to learn some kind of a behavior that it needs to depict. And this particular thing, reinforcement learning, is very well used in your many use cases such as stock market predictions. Like whenever the model is able to correctly predict that what kind of move I should be actually making in the particular market situation, the model is given a reward. That means it is given a point. And whenever there is some kind of a loss that we expect, we try to give that particular thing a punishment. That is like all the types of machine learning that models that we have in here. Now the thing is, now that you have understood what is machine learning, at least at the basics of it, then why do we need to learn these sklearn called library? Like this is the short form that we have. The whole full form of this sklearn is nothing but Scikit-Learn. This is what we have. Like this is the full form of this library. Now, why do I need to learn this? Let's just talk about this. Now, the agenda is that any kind of model in machine learning that I'm talking about, whether that be supervised, unsupervised, or any kind of model, that is based on mathematics. Okay, and there are several things associated with mathematics. And if I like go into a little bit deeper part, imagine like scientists build an algorithm or anything like that. They build an algorithm, and there are two things now. Let's just say you are building your own project. So what you can do is, like if this algorithm was made in 10 years, for example, you can either start from making this algorithm from scratch, or what you can do is, like since they have created this algorithm, you can just simply try to implement it in your particular case. Now, this is the same example I usually try to use in my class, that let's just say that you have a bulb that goes out. In your house, there's a bulb that basically goes out. Now, there are two ways in which you can possibly fix it. Either you can take the first approach, that is go mining, find tungsten, go find, silicon, melt it into a glass, create a fuse, create a filament, and then like from scratch, from step one as mining, you just go from step one as mining. You can just simply, like you will follow some steps and you have a new bulb with you. Fair enough, sounds good. But the other approach is that either I can just go and see that if other person has made like this bulb, I can, like choose the best bulb possible for my particular housing that might not go out, or you can like fuse out in some particular time, and I can get the best bulb possible that is actually has been made now. Now, logically, I think so. If I assume that you are as the same page with me, I think the second approach is what makes sense to me more. I hope that makes sense. So for that particular reason, any kind of algorithm in machine learning, instead of me mathematically implementing it with, from the very basic. Like I just try to create each and every step of it. Mother, I just try to go for gradient descent. These are the some steps we will be discussing in the future sessions. I'm just trying to explain it to you. For example, mathematically, I don't want to involve probability, and I don't want to involve probability at its core. I don't want to like involve a step which is basically, let's just say, your hyperplane calculation and so on. So if I don't want to get into that particular part, because first of all, perfecting this part would take me a lot of time, and also it is unnecessary to do all of this heavy lifting it if that thing has been done in the past. So for that, what we do is, instead of writing your whole code from scratch, we use a library. I hope so that you must be able like be familiar with the term library. Anna, what is a library? Now, very simpler terms, just as in schools and colleges, we have libraries in which we have some sections of books that store knowledge for us. In programming, libraries basically contain some pre-written code that we have or maybe which we can use. And for machine learning, the most used library, even in the industry and anywhere you talk about, is nothing which we talked and saw today, and it was sklearn. Okay. It is, you can say, the bread and butter of machine learning. And if without this library, I'm not saying that you cannot implement machine learning model, but you can do it much faster. Now, this sklearn library basically is constructed of, or you can say is built upon two things. First being your NumPy library, and second being your Pandas library. Okay. And the best part which I like about this library is basically that it is open source. That means it does not have any, copyright issues or anything like that. It is something which is open source. Right? Yeah, it is open source. Now, what we actually do with it, I'll just try to show you how simple it is to basically, implement this type of algorithms is by. We can just simply see that I showed you that this is basically built upon your NumPy. SciPy is an extension of NumPy, and we have Pandas on top of it, and then we have sklearn library, which is basically like the top floor of data science building, and it is actually the library that is somewhat based on these two libraries. Like it consists of a lot of things that has to do with Pandas and NumPys and whatever we have. Now, again, I told you this particular part as well. It is a consistent part. It has the robust documentation and so on. So maybe I'll try to share this presentation with you at the end of this session also. So don't worry about it. Now, let's just come to a part that means like, how can you actually use this particular library? For that particular reason, what I can do is I can simply just use a platform such as I can go to Google Colab. This Google Colab is an environment which allows me to access Jupyter notebooks that can be hosted on this platform. This is completely free. Just go and open a new notebook. It is very simple. You can see it is a button over there which says new notebook. Just go over there. And once you're able to land into this particular page, this is what we have an environment of Jupyter notebook. Okay, I'll just quickly make you familiar with this environment. Here you can see that I have, if I come here, you can see that I have this connect button with me. Before that, you can see that there are some things such as files, we have edit option, view option, insert, runtime, tools, etc. etc. If you recognize this particular icon, you must be able to decipher that this is nothing but your Google Drive. That means any work you are going to be doing is going to be stored at Google Drive. And the extension of this notebook is basically an IPyNB, that means integrated Python notebook. Okay. So let's just say I create, like I rename this part as, let's just say, sklearn 101, something like that. Okay. I just change the name of this particular notebook like this. And what I'll do now is that I'll come to this connect part, go here, and I'll see that where is basically this option called change runtime type. If I click on it, you will be able to see that this particular environment supports not only just Python 3, or you can say the version which are greater than 3, it also supports R and Julia. Okay. So what I'll do is I'll just simply select this Python 3 and I'll go to the save part so that I'm able to use this notebook for Python. And I'll just simply hit on this button called connect. Now, what does this button connect to? Like, where is this thing going? The thing is that instead of using your native environmental resources of your laptops or any kind of thing that you're on, it is now getting connected to, you can see, Google's backend engine. That means you do not need to worry about how powerful your system is. You can just simply rely on that particular systems that you have in the backend. That is what we have. Also, I'll try to show you the best possible thing here is that if you go to this part, you can see that you have many data sets to work with. That means in the later on sessions, when we will be basically talking about, building these models from scratch and so and so, or maybe when I'll try to implement a project, you can see that I have data sets available with me. And I have things which I can just directly import from this particular file and, like just work on with it. If I had to use a custom data set, in here I also have an option to upload files. I just have an option to upload files. But just keep in mind that the moment this notebook will get disconnected, the uploaded file will also disappear. Okay. So that's like a quick overview of this platform. Now let's just hop in back. How do you install this library? Now, in this kind of environment, whenever you have a text cell and a code cell and an output cell kind of environment, or you can say the cell environment, what we usually do is we start writing our terminal commands, but we start it with an exclamation mark. Without this, you can see that it is going to, like, even if I type the, like command correctly, you can see that it is going to be giving me what it is going to be giving me. It is not defined, although it being a terminal command. So what we usually do is we go here, we go for an exclamation mark, and then we try to write the terminal commands that we have. Just as in this case, we have pip install. Now the library that I'm trying to install is sklearn. So I'll just simply go for pip install sklearn. And how do I run this part? Either I can just click on this button. I hope it looks similar to a play button. So you can just simply click on it and it is going to be, running this particular cell. Or in the bracket as well, you can see that it is saying that you can just simply press Control Enter, but you can also press Shift Enter, because it is going to also create a new code cell in which you can type things out. So you can see that it is going to be like collecting the sklearn library, ignoring some sub processes because that is going to be a problem. But then it is going to install your sklearn library with you. Okay. If let's just say I wanted to check what sklearn version am I using, you can use it by this particular thing. That you just simply import sklearn and print the sklearn version. I'll just try to do this so that we can see it. I'll just simply go and say import sklearn, right? And maybe do it in the next cell. After this importation part, I can go and say print sklearn dot underscore version, then underscore. If I'll do this, you will be able to see that I am running as of now 1.6.1 version of my Scikit-Learn library or sklearn library. That is how it is easy to install this environment in your Jupyter Notebook. Talking about any kind of system such as Windows, Linux, or Macs, any kind of systems, you must be working with a platform called IDE. That is basically nothing like IDE, integrated development environment, and that can be such as VS Code. And nowadays people work with, let's just say, anti-gravity, right? And also you might be using Kiro. That is also a very famous platform nowadays. So how do I install this library if I wanted to use in these particular environments? Just the same process. What you do is, for example, if I try to open, let's just say, anti-gravity here, you will be able to see that once it launches, I have an option to just simply go to this terminal part. I'll just click, let's just say it is going to be giving you this particular thing. Let me just close this. So what I'll do is I'll just simply type the same command. That being, I can just simply go for pip install sklearn, right? And it is going to be installing that same library of sklearn. You can see that it is just downloading all that part. And once this is, implemented, or you can say installed, you will be able to use sklearn in that particular library as well. Okay. Failed to build. Okay, that's particularly because I'm trying to install it in this particular project, but don't worry, you will be able to do it on and on as well. Okay. Either also you can just simply go into a command prompt or a terminal shell, and here also you can simply type this same command. So the command is same. You got that part. Like this command is same. This command is all you have to run, and it is going to be installing this library globally. Now the thing is, there might be also some other libraries other than Scikit-Learn, but why did we choose this over any other library? The fact is that instead of just having only the models, or you can say the algorithms, like it does not only just contain models, it also contains other things around the model which are very, very useful and are actually the majority part of any kind of algorithm that you are going to be making. That being, it allows us to perform pre-processing steps. It allows us to divide our data into training and let's just say testing. I'll explain it one by one what do I mean by all of this. And it also allows me to evaluate my model once I'm done with it. These are like the basic things that it allows. Apart from it, it also allows me things such as building pipelines, applying transformations, which are fairly something. Both of the things can be done manually, but we have the option of this also in this library. So that is what it makes it a one-stop solution for everything. Let's just first of all talk about models. Now, any model you pick in supervised learning, unsupervised learning, you have an option to build that in just 1 to 2 lines of code. That is all you need in this library. So it is fairly well easy. Talking about your pre-processing. Now, what do you mean by pre-processing? Now, since you understood from your journey with computers, like it at its fundamental part, we know that a computer doesn't really understand text or any kind of thing apart from any kind of data. It does not really understand these kind of stuff. Computers only and only understand what? They only understand numbers, and that too, the computer only understands truly the binary system, that is zeros and ones. That is what the computer understands. The same goes with the model that we are trying to make. That means, let's just say that what I wanted to do is, I wanted to, let's just say, filter my emails into spam and non-spam. That means I must have some kind of text with me. And let's just say, since I mentioned that I need to have a label involved, so let's just say I have a label. That means, let's just say I have spam. And here I have some text like free cash or anything like that, like any kind of usually text that we actually see. You must be seeing that part. And that is what I'm actually talking about. Now, both of the things that you can see on my screen, like the data is going to be like this. I don't think so that the text we get usually is just the numbers. We have labelings in text and everything like that. I don't think so I text my friends as 1001 or 02 say hi. I type the word as hi. That is what we usually do. So now what to do if your data is like this and the model understands the numbers? What I usually do is I try to convert this data into what? I try to convert this data into numbers. That is one thing. Now just imagine, let's just say the model had to like predict something, but to predict something, it also requires some data with me. I need to have some data, but just imagine that the data is actually not complete and is basically missing. Don't you think so that it won't be able to predict anything because you're not giving it any basis by which it has to predict an outcome? So that is one problem which we usually have whenever I'm talking about, machine learning models. So to solve these kind of problems, like these are very shallow problems, I'm just giving you an idea. What we have is we have to apply the process of pre-processing on the data that we are going to be giving inside our model. And this is a really, really crucial step. That's why I always mark it with a dollar symbol, implying that it is like conditionally the most important step. Because the thing is, either I can also automate this part and this part, but the pre-processing part is something that can never be actually automated because every data set that you're going to be working with involves pre-processing differently. But we will be exploring whenever I'm going to be working on a data set. Okay. Now, what do I mean by training and testing? What do you really understand by this word training and testing? Now, let's just imagine that whenever we are actually students, we are given like some data to, train ourselves on, whether that be, let's just say, English literature. And we are given some English books to learn from, like English literature we have. Maybe we have, let's just say, mathematical formulas. We have science books and so on and so on. Right. And this is what we basically can call as training, because I'm trying to make you understand concepts. I'm trying to make you understand what kind of things are there in the literature. Maybe I'm trying to explain you language here. Maybe I'm trying to explain you mathematics here, operations, anything. This is what I call as training. Now, if I make you understand all of this, don't you agree with me that I also need to be, maybe testing how well did you learn? Because I don't think so that without this testing process, I would be able to understand that how well did you actually understood the concept or understood the training part or anything like that. So for that particular reason, we have a concept, or usually we had a concept of exams, right? I had the concept of exams in which I can say that I am doing what? I am testing you, that how well you have learned that part. Now the exams, of course, are going to be saved from the data that I have actually given you for training, or you can say at least going to be similar than that. Maybe the answer might not be there in the data directly, but I will give you some kind of a hint, or maybe some kind of something by which you can actually refer to your training data and be able to give me some prediction, and I'll just test you out how well did you do. Now just think about it. Whenever I'm going to be like splitting, or you can say give for any given data set that I will be having, you got that part that what I need to do is I need to, like, first of all divide it into training, and I also need to divide it into testing. And this training and testing needs to be on the same data set, because let's just say that whenever I am going to like give you data for training, and for the exams part, let's just say you learned English but I give an exam of maths, it is inevident that you won't be able to perform. You will be failing actually, because the data that you have actually learned from is not reflecting what I'm actually testing you for. So for that particular reason, this split has to be first of all on the same data set. Then just think about it. Don't you think so that this training data needs to be more compared to testing? Meaning, if I talk about this particular analogy only, I think so that the data that you were also given to learn from was huge. Let's just say that we had books, we had like, maybe we had some videos to watch, maybe we had lectures or anything like that. But whenever I'm talking about exams, it is just hardly of, 2 to 3 papers maximum. Or maybe I have seen one paper exams also. So compared to a whole book that has, let's just say, 300 pages, or maybe even more, or maybe less, like I'm taking it average as 300, or the videos being, let's just say, of 9 hours and so and so. Just imagine that the testing part is quietly fairly low. Why is that so? Because I don't need to know that you have understood each and everything from like in great detail. I just want that if I give you something to answer, are you able to do it accurately or inaccurately? How accurate are you? So for that particular reason, the split that we usually follow is basically 70% data is kept for training and 30% data is kept for testing. That is like the split we usually follow. And this splitting part also needs to be shuffled. What do I mean by that? Let's just say that imagine you go to college. And whenever we go to college, like talking about myself when I was in college, what is the first decision that we make whenever we go into a new semester? Like the first decision that we make whenever we enter a new semester is to like attend all classes. That is like, like the first decision I guess everybody makes whenever they enter their colleges on the first particular day of their first, like new semester. But what happens at the end of the semester is that, let's just say this is your nth class, and you will be seeing that you are absent, or maybe you did not. Like, I'm not promoting this, I'm just giving you an example because this is what I have usually seen. So what do I mean by this is that if I look at the data You must be present in each and every class just like this. And if I was to look at the end of the data, you will be absent in each and every class just like this. But the fact is, if I wanted to like predict if you will come to the college or not, I don't think so. I can use this pattern. Like there will be this thing which is going to be followed in the initial part of the data. That means, let's just say for first 5 days, this was the situation. And for the last 5 days, this was the situation. Now, just think about it. If on the training part, you had seen that a person arrives at each and every classes on each and every day, how will you be able to predict that if that person is going to be absent or not for any given particular class? That is the situation. So for that particular reason, this train test split, which I just showed you, needs to also be what? Needs to be shuffled. So there are a lot of things involved in this particular splitting part, and like shuffling, and like keeping that same set of shuffling. So this is what the beauty of this particular library is, that this heavy task of training and testing, or this like splitting our data into training and testing, is also done by this particular library itself, and that is just in one single line of code. Lastly comes with evaluation. Now, what do I mean by the word evaluate? Now, whenever I talk about, like, let's just say using the same analogy of exams and like training data and so and so, I hope you get that part, that we used to be awarded a thing called marks. Now, the thing is, let's just say out of 100, you were able to attempt, let's just say 5 questions correct. So this was like a given score that was awarded to you. And if you were able to make like most of the questions correct, this is what you used to be given. Let's just say 95 was the score that you were given. Right? That is what we used to expect in the cases of marks. Now, this marks, which I'm actually talking about, is type of a metric that we can use for evaluation. And this same kind of evaluation metrics we have available in the sklearn library itself. And what are those? I'll be explaining you in the future videos, but I hope so you get what we are trying to do. And I'm just trying to give you the underlying things that we have in this particular library. Lastly, these are some advanced things. And what do I mean by these advanced things? They are not actually that difficult to understand, but the thing is that these are some processes that one understands whenever they're implementing stuff. And if I give you a little bit idea, like the pipeline basically means that if I had to apply some processes or maybe multiple processes on a given data, instead of me manually trying to apply it on each and every data point that I'll be seeing maybe in the future as well, or maybe some new data comes in of the same type, I can just simply build a pipeline that is going to be automating that particular task. That means, let's just say if I have a data point with me, some pre-processing steps are going to be applied. Then, it is also going to pass into some transformations if needed. Then it is going to be needed, like into the model itself, and then there needs to be a prediction. So we have a certain pipeline that we can actually use. So that actually eases the process of whenever you have to build production grade models that, will involve a lot of data points to come in and go out each and every, like second or even nanoseconds. So for that particular reason, we design a pipeline in that particular case. Talking about transformations, this involves a little bit deeper understanding of ML that comes with the algorithms that I'll be teaching you. But to give you an overview, the thing is that there are certain algorithms that are sensitive to some things. For example, if I have one feature which is very large compared to some other feature, just think about it. Don't you think so that these large values are going to be dominating this particular lower value? Like if it is a small value, this is what we have. So some algorithms are like sensitive to these kind of situations. So what we do is we try to apply some transformations so that this kind of scenario does not happen. And how will I know what type of transformations to apply and so and so? That is when we will be discussing about algorithms in that case, like which algorithm needs which kind of things to be taken care of. So like in one particular step also, I can just apply this transformation. This is how easy it is used. Like that is why what I meant was that this is why this whole library, which I'm showing you, is so popular. It is also asked fairly well in the interviews also. The same question can be asked in the interviews also, like why is sklearn so popular? So you can just, now like why it is so popular. Right. Moving on. This is like also having some built-in data sets that I'm going to be showing you in the future sessions, of course. But what do I mean by these built-in data sets? Now, the thing is that instead of, like whenever I'm trying to learn ML as well, or maybe whenever I just want to, build a model in that same sense, what I can do is I can, have some test data sets to work with, or you can say toy data sets, which, does not involve cleaning. So first of all, they are small. They also do not involve cleaning because they're already clean. And like they do not have any missing values or, like incorrect values and so on. So it focuses you to build a model rather than to, be involved in these processes such as pre-processing and, like applying some transformations or anything like that. So that is what we have in this case. So this library also beholds some very popular data sets that are still used for showcasing how an algorithm works. First being your iris dataset. It is basically a data set that is going to be having some, distinct classes of uh, flowers. Like if I hope that you must have seen flowers in your life. And flowers, like everybody likes flowers, I guess. So the thing is that in this data set, we have three different species of this particular flowers. We have three different species to work with. Like I can name it as well, but I would really like if you just go and look into this thing as like, like a homework maybe, or, like just look into it. It would be fun. Then we have a data set called diabetes. That means we have a data of all the patients that basically either suffer from diabetes or do not suffer from diabetes. And we have a risk level associated with it. That means given their age, given their sugar levels, given their insulin levels, given their blood pressure, and so other such parameters, we are able to predict that if that person has a higher probability of having diabetes or not. So this is a very interesting data set that we will be also working with, right? Then I have like the load wine data set. That is basically another classification set, which is basically having some, features, and based on those features, I'm able to, like classify if the wine that I'm looking at is a red wine or a white wine. That is what we have in the load wine data set. Along with this, I also have a data set which is basically very, very popular in the world of OpenCV when I'm talking about computer vision, when the camera is used to detect something. That is the case. So another data set that is very popular is called load digits data set. And this is a very interesting data set which I'll also be working with you in the future. Like load digit data set, if I try to show you, you will be able to see that we have this kind of data with us. That means we have handwritten images of, like some numbers that are given to you, like 0, 1, 2, 3, 4, 5, 6 until 9 it is there. That means like given the pixel values, or like if I wanted to show this to a model, that model should be able to like recognize that this is a 0, or maybe this is a 9, or maybe this is a 6, and so on. So this is also a really interesting data set that we have in sklearn library. So we do not need to actually worry about where to get data sets to start, at least. Maybe for given problem statements, we need to find a given data set, but for starting this journey, we do not need to look forward for finding any kind of data sets that we have. Okay. Now, this is the part which I totally showed you. This was the same thing, right? And here is the most interesting part. Now, the thing is, the most interesting part about sklearn is what I feel is that if you look closely to this code, we have three processes with us in this case. That is, I have an initializer or an instance of the, like which model I'm trying to be using. Let's just say that in this case, I'm having a model, a random forest classifier. Even if you don't understand what this algorithm does, just imagine that you have this as algorithm 1. That's simple. Okay. Next, I need to make this algorithm understand what type of data that I need to fit it into. So for that particular reason, I have a model.fit function that is going to be training our model on the data set that is given, or the training part of it. Okay. And then I have the thing called predictions, which is just nothing but model.predict. This is like the whole machine learning, you can say, boilerplate code that you can use anywhere. Let's just say you wanted to use a different model. So what you can do is you can just simply replace this particular part with the name of a different model. In this case, you can see that this is linear regression. That means now I'm trying to move with linear regression. So you can just see rest everything in this case remains the same. Everything is the same. The only thing which I have changed is nothing but changing this model. Also the import part, like that's given, but you get that part. Like I'm just only changing one particular function, or you can say one particular instance, the model name which I'm using, and that is how easy it is. Even if I talk about algorithms which are different from supervised learning, I can say that we have like clustering, which is a part of unsupervised learning. Here also, I just need to specify the model, maybe some given parameters, and everything else remains the same. So that is how easy it is to basically build models with Scikit-Learn. So that is why this library is really, really popular, and I really love this library because I have built many, many projects with this library. Anna. Now, let's just go into a little bit detail of the machine learning. That means if I talk about this supervised learning, like what exactly was the supervised learning we have seen, but under this supervised learning also, we have just two types. And what are those two types? I have like with me, first being classification, and next being regression. Chika, these are basically the two types in which you can just divide your supervised learning algorithms. Classification standing for whenever I have to predict some, you can say, like you can use the word predict when I have to predict something into discrete categories. Anna. And what can be those discrete categories? For example, you can predict like for a given image if it is a cat or if it is a dog. If it is, let's just say, maybe you know, male or female, anything like that. Or maybe what color it is, like red, maybe is it red, is it green, is it blue, and so on. Like whenever you have certain distinct classification categories with you, which you can, like I can say, I cannot say that there is going to be anything such as half a dog and half a cat. I don't think so. That is basically what it is, like 1/3 of a cat and one like remaining for the dog. This is not something which we expect. So the thing is that we either need to have a dog or either we need to have a cat. That is what I mean by discrete part. The next thing being like in case of regression, there is the only change that we have is basically now the thing which we are trying to predict is not discrete. It is now continuous in nature. That means now imagine, let's just say I want to for a given for a given age, I want to predict height. Okay, like height is something which can be discrete, continuous in nature. Meaning, I don't think so that if someone has the height as 180 and like next one is going to be having like for a sample, maybe I have 185. Don't you think so that all the values in between of this range is also possible? I can also have 181 as height. I can also have 181.5 as height, maybe 187.5, like all the values in between, where actually there is no given discrete values with me, like any kind of given label. I have these things as continuous. This is what I mean by regression. That means in here, I am trying to predict a variable that is going to be continuous in nature. If I try to make you visualize this part, if I try to visualize this, you will be able to see that like if it is here, I'll just try to show you this part as well. This is like how your basically classification data might look like. That means if you focus here, you can see that we have blue dots with us and also we have green dots with us. That means these are the two distinct data points that I have, which I have also labeled as class A and class B. Now, since there is nothing such as class A 0.34 or like plus B point, like that is something which is not possible. Can you see that either I can build a model or like I can just do anything, but what the ultimate thing needs to be that I need to differentiate between blue and green. Maybe I can draw a line over here. Maybe I can have some, like distance based algorithm, anything, but you get that part, right? But whenever I am trying to, talk about something such as I said, weight. So in that particular system, what will happen is that I will have a situation. Let's just say that whenever I'm talking about height or weight, let's just say here I have age with me and corresponding to age, I am trying to, like calculate height of a person. That is what I'm usually trying to do. In that case, of course, I don't think so I will have one as here, then the another maybe as here. In between these 2 points, the data is possible. That means someone can also have an age in between this particular thing, and the height value also can be there. So for that particular reason, the graph usually looks like this particular thing, like it is going to be continuous in line, or at least appear to be continuous. That means the points are going to be very, very close to each other. That is what I basically mean by the continuous data. Like normally as a trend, you must have seen that at a given certain age, with age your height increases, like for a given certain age. After that, it might be variable for everyone. So this is what I'm talking about. Okay. Now moving forward, this is like the core workflow which I just told you, that whenever I am working with the data outside my Scikit-Learn library, I can just load that particular data set with me, and that is through this Pandas library. I'll tell you, and I'll showcase you this. Then we have like splitting our data, like in between this pre-processing. I have just tried to keep this very, very simple. In this case, you can see that I'm trying to split it into training and testing. Then I'm trying to fit it. That means training my model into the particular data set. Then I have the option to predict my options, like whatever given part I have given for testing. I'm using that test data to predict how the values are going to look like. And based on those predictions, I'm trying to evaluate that particular model's performance. That is what we have here. So this is a little bit difficult. I'll come to this part. This is basically a classification. Just I showed you like blues, oranges, greens, right? Moving forward, this is like a regression part, like your actual data points, and we just try to fix this part like this so that it is much closer to these points. This is like your regression part, right? And it is a very interesting concept. I wish that we should cover it today only. Let's just try to look at this particular thing. Okay, let's just try to look at this particular thing. Now, what is this in your opinion? Like, what do you think? So, like people who might watch this later, just think it for yourself in your mind as well. Like, what do you basically call this particular thing? I think this is a dog, and despite this particular thing being a dog, I can also say that this is basically a Labrador, right? Moving forward, I think that this particular thing which I am looking at my screen right now is also a dog, but this is basically a German Shepherd. And similarly, this is basically a Golden Retriever. Okay. Now, if I ask you to predict what is this, if you said that this is a Labrador, this is like a German Shepherd, and this is like Golden Retriever, like being very, very specific to what we have basically, learned, like I'm looking at this particular breed only, and I'll say that only for this particular breed, I'll say that this is a dog, then I won't be able to say that this particular thing is going to be a dog. So this phenomenon of, like actually, instead of, like learning patterns, like instead of that, just a second, instead of learning patterns from my data, if the model is actually memorizing the data, that means if the model is, let's say, memorized the data itself, like it just memorized that for this given color only, and for this given size only, and for this particular orientation only, I'm going to be calling this a dog. Do you think that that model is good? First of all, it is not good, because it is not going to be performing good on new general data that I'll be giving it. So this phenomenon, that where it, instead of learning patterns, it tried to like it memorized data, is what something we call as overfitting. Okay, that means the model is not actually learning patterns, it is just memorizing the data points. That is something which we can observe in machine learning frequently, and that is what we have to try to figure out. Now, if I ask you, like, why did you call this particular, or even not if this image, like, why did you call this particular thing as dog? Now, some of you might say that because it has 2 eyes, it has 4 legs, it has 2 ears, and it has a tongue, or maybe something like that. Now, if this thing has a nose, if it has 2 eyes, if it has 4 legs, Can I say that this particular thing can also be something called as dog? Like, do you think so? That logically, if you must have seen this thing maybe in the real life as well. I think this is not a dog. This is a cat. But I think so. It also has like two eyes. It also has nose. It also has four legs, and it also has 2 ears. So how did I, like differentiate this part? Why do you think so that I am calling this as a cat and I'm calling this as dog? Because first of all, as we know that they come from a different species family and they have like they exhibit different behaviors and have different genetics. But if the model, let's just say, only on the basis of, let's just say, the parameter that it had like two eyes and a nose, it was just using these two factors classifying that this is also a dog. That means my model is not able to capture, like not able to not capture patterns. Like, I'm not writing the full sentence, but you get that part. Like, if it is not able to capture patterns, I basically label these kind of models such as under fitting models, or you can just simply label this term as under fitting. That means that the model that I'm trying to build is actually too simple. Right, it is too simple. That means, just given the fact that two eyes and a nose leads to a dog, it will just misclassify this also. Like, given that, because it is just looking at two eyes and a nose, and it is just also going to be calling this as a dog. So that is the thing which we try to control. Like, I just don't want my model to be underfitting. Like, I just don't want to be having an underfitting situation, and I also don't want it to be having an overfitting situation. I basically am looking for a thing which is basically somewhere in between of this two situations, and I label this. This is not something which is fixed. Like, I cannot actually pinpoint at as a like this as a metric, like 0.5 or 0%, nothing. This is like a sweet spot that we actually target. Right, this is like a sweet spot that we actually target whenever I'm trying to build a model. Now, there are certain challenges. Like, this is what makes data science really interesting. Like, why and how I can pass, like I can just achieve this particular situation. That is something which we have, which is somewhat, very interesting part between your machine learning model. And like, this is like the ultimate goal of any model building part. Now, to conclude, like whatever we have learned, what we'll be learning in the tomorrow's session, in the next session, is that I'll be actually talking about how do you actually clean your data. Because you must have learned till now that if I have, like, this is a phenomenon, this is a very famous phenomenon, garbage in, garbage out. That means that, like, if I even write this part, like garbage in, garbage out. What is this? This means that if any model I talk about, any ML model, like any ML model, you saw that part that it was basically being trained on data, and it depends really how good your data is, how simple your data is, how complex your data is, and so on. That means inside this particular model, if the data that I am passing is actually messy, like it is a messy data that I'm passing it, and by messy I mean that it has, let's just say, missing values which I can say as NA, not available. It has maybe duplicate values, can be a problem. It has, let's just say, like too many features or too many columns, like features are very, like a lot of features I have. Maybe incorrect data type, like I have incorrect data type. So this is what I mean by messy data. Then I hope so you agree with me that the model is going to be, of course, not perform well, or maybe is going to be failing. So like this particular process of, data cleaning, in which I have to convert this messy data, first of all, into clean data, is what is really important and is the most core step of any kind of machine learning model building process. right? So that is what we will be covering in the next session. So till that, I hope so you understood each and everything which I was talking about, right? And like this was like the intro to your sklearn library. I hope so you must have also imported this and also like able to check this particular part. From the next sessions that we will be having after this, we will be moving forward for hands-on implementation, because today I gave you the theory part that you had to understand majorly, and then after this session you will be able to understand, after this knowledge that I have given to you, be able to actually have an hands-on, why did I get off, sorry, hands-on implementation afterwards. Okay, so thank you for joining, guys. I hope that I was clear enough, right? So that is one thing. Baki, I'm so sorry I could not read these comments when I was talking about this. So it says, like, I'll just first of all stop sharing my screen. It says, "Hello, sir. Please make it on to end job ready projects in data science." Yeah, of course, it will. I am actually planning to do that in the longer run. But if I just made on end-to-end, like read like job ready projects on data science, then the core concepts that you actually need to build these kind of things would be like not a thing with you. So that is what my goal is. Like if I just covered this part as well, and then I move on to that particular part that actually has this, like based on this core knowledge, then if I move forward for this end-to-end projects, that would be really, really great. So that is the thing which I'm looking forward for, right? Baki, that's really nice. And thank you so much for joining, guys, at least over there. So maybe I'll see you in the next one. So till then, keep learning. Bye bye. See ya.